think he's got that one, but he definitely multiplying and dividing missed. So this one,
Because you gave
4.
4. I don't know if you did. Do you want him to have all 4?
Yep. Because I'll put them in. So 1, 2.
They hand them in.
Yeah. I'm just 3.
Thank you.
And 4.
Thanks a bunch.
Okay, we are going square roots. So the last part of this unit is doing mathematics with square roots. And what is a square root? And what are perfect squares? So this is on page 40 of your notes. So the first thing we can do is, if you have a highlighter and like to do highlighting in your notes, so the square root is a number that when multiplied by itself is the number that you were given. So we would say the square root of 9, when you're trying to find the square root of 9, you're saying, what number multiplied by itself would give me 9? And the square root of 9 is 3. Now, something interesting about square roots. When you're doing a square root, the answer you give is always the positive number. So even though, did you know that -3 times -3 is also 9? But when we write the square root of the number, even though -3 would also give you 9, the square root of a number is always positive. And that's partially so that our calculators work. When we hit the square root button on our calculator, we want it to give us one number. The calculator would be confused if it had to give more than one number. So this is why it's always the positive one that comes up. We call a number which is the product of two equal numbers a perfect square. So for example, 4 is a perfect square. Perfect square. Because it's equal to 2 times 2. 16 is a perfect square. Why? Because it's equal to 4 times 4. 1 over 25 is a perfect square because it's equal to 1/5 times 1/5. So anytime you can multiply two rational factors together to make something work out perfectly, you have a perfect square. Okay. So there is the list of the first whole number perfect squares. Can you tell me what the next 3 are after 25? 36, then 49, then 64. Because this is 6 times 6, 7 times 7, 8 times 8. Okay? Have you seen the square root symbol before? Do you know where it is on your calculator? Okay? So can you show me that you know where it is on your calculator by showing me what the square root of 5 is equal to? Are you done? Because I don't see you writing anymore. You're handing it in right now, or are you still working? Okay. How many more? Okay, good. Oh, so you're going to have to, yeah, so go set up now, go back to this one, number 2, and now try it. No, yeah, but I want to do square root of 5. Right, but now you should be, if you turn your calculator this way. Oh, you're not. Yes, that would be better. Your calculator. And then it keeps on going. Yes, so on this one, the square root sign is there, so you have to go second. And then the square root sign right there, and then write 5. And then push enter. Yes. We're gonna get to that one. You're working ahead. This one. Square root and then write 5 inside. It gave you a bracket. Sometimes it's nice to close the bracket. There it is. Hey! Do you notice this is a decimal that keeps on going without a pattern and doesn't repeat? That means this is an irrational number. Do you remember the symbol for irrational number? The Q with a line in the top. Okay. What's that? Those kind of things, that's going to be on your test, yeah? Okay. We're going to schedule it pretty soon. Probably we can even put it on the schedule for today. We're going to do another quiz, and then we're going to do our test. So our quiz will be next week, probably Tuesday, and our test can be on Thursday for this first unit. No, can't wait that long. Okay. So let's write that up so we don't forget. We're going to have and then test on Thursday. I will give you more details about the quiz on Monday and more details about the test on Wednesday. Okay, so without a calculator, when you have the square root of 81, you're looking for what times what is 81? 9. Now, 225 might be one you need your calculator for. Unless you have your 15 times table memorized. 15 times 15 is 225. Okay, and this part is just describing that when we do a square root of 64, we only write the positive answer. If we want to write a negative answer, we put a negative inside or in front of a square root sign. And this is going to come up in algebra. So just to see where this is going, in algebra, you might have this question: something squared is 64. Does it make sense that 8 would work? And does it make sense that negative 8 would work? Now, in algebra, when you're solving something, what you do to one side of the equation, you do to the other. So in order to get rid of something squared, we square root. So we would square root the x squared, and we would square root the 64. And because it could be positive or negative, we write a positive or negative in front. Because if we just wrote square root of 64, that would just mean the positive 8. So then we write the positive and the negative out in front, and our final answer is positive or negative 8. Now here it says evaluate if possible. So that kind of implies that maybe some of these are impossible. If we look at the first one, square root of 1 is equal to 1, because 1 times 1 is 1. And then the negative would still be out in front. In B, what times what is 400? 20, good job. Or if you needed your calculator, that would be fine. C, what times what is 2500? 50. And if you needed your calculator, that would be possible. And then when we get to D, what times what is negative 49? That's impossible, because 7 times 7 is positive 49. And negative 7 times negative 7 is positive 49. In order to have the same number, when you multiply the same number by itself, you will always get a positive answer, whether they're both positive or both negative. So for this reason, this is an important rule in mathematics. You are not allowed to take the square root of a negative number in the real number system. I should. Well, it's just, we've actually seen this already once, right? We did this when we did our grocery store math, when we were organizing. There was a negative inside. You're not allowed to take the square root of a negative number. If you try it on your calculator will get mad at you and say error, or not in the real number system, or try it. I'd like to design a calculator when you do things that aren't allowed that gives you a tiny electrical shock. Right? And then you'd realize and you'd be like, oh, I shouldn't do that because that's not allowed. It'd be a nice little gag gift. What does your calculator do when you get square root of a negative number? And it's like, oh, it just says error. Here, try mine, see what happens. And that'll learn them, eh?
To see a bunch of classes long.
Yeah. Be a good gag. If it's like that, do you remember that gag where you're like, hey, you want a piece of gum? And then I pull it out and it's like a little mouse trap and snaps your finger? You never seen that? And then there was pens where the clicker was electrical shock?
Oh, yes.
Yes? You remember that one? Oh, I saw it. You laugh. So much fun. Okay. Okay. Next, we're going to do the same thing, but think about decimals. Okay? So a fraction is a perfect square if you can write it as the product of two equal fractions. So for example, if I took 2/3 and multiplied it by 2/3, I would get 4/9, and 4/9 would be a perfect square fraction. Okay? Notice the top number is a perfect square and the bottom number is a perfect square. That's kind of the hint to realize that a fraction is a perfect square. If a decimal can be written as a fraction that's a perfect square, then the decimal is a perfect square. So we now know that 0.4 repeated, remember we can change 4/9 to a decimal, is a perfect square. Okay. So to find out if something's a perfect square, if it's a fraction, first of all, you reduce it to lowest terms. Is 8/18 reduced to lowest terms? No. I can reduce 8/18 to 4/9. And since 4/9 is equal to 2/3 times 2/3, this one is, yes, perfect square. When we get to B, it's already in lowest terms. The top number is 4 times 4, but the bottom number is 5, not a perfect square. So B would not be a perfect square. C. 9 is a perfect square because it's 3 times 3. But 2 is not a perfect square unless you make a mistake with 1 times 1. You know what? That's one of the most common mistakes ever. 1 times 1 equals 2. You wouldn't believe how many times students make that mistake. 1 times 1 equals 2 is one of the most common mistakes ever made. Why is it one of the most common mistakes ever made? Because it's so easy that you don't even think about it. And then your brain says, hey, do you know what else is easy? 1 plus 1 is easy. And you're like, yeah, it's 2. And then you write down 2 for 1 times 1. So we put an X by C. Now for D, when you get to decimals, this is where you can use your calculator. So if you want to check if it's a perfect square, you go to your calculator and you check what is the square root of 6.25. And you type it in. If it works out to a nice number, which it does, that tells us that 6.25 is equal to 2.5 times 2.5. And so this one is, yes, a perfect square. Mm-hmm. 0.5 times 0.5 is the 0.25. Interestingly, 25 times 25 is 625. 2.5 times 2.5 has the same numbers. Do you know the trick for multiplying decimals? This has 1 decimal. This has 1 decimal. Your answer needs to have 2 decimals. Add them up. So the answers work out to be the same, but you have 2 decimals. Do you know? Oh, I love math. Sorry. Why does this work? Well, how would I change 2.5 to 25? I'd have to multiply by 10. How would I change this 2.5 to 25? I'd have to multiply by 10. So that means the answer here, because I've multiplied by 10 twice, is 100 times too much. When you divide by 100, you have to move the decimal place over 2 times and get 6.25. And then E, did anyone get, can someone tell me what the answer to this is with their calculator? And it just goes on. Does it have a pattern? Does it repeat? No. So this one, it's an irrational number. Remember that symbol for irrational numbers. So if you do the square root and that decimal doesn't repeat, doesn't end, then you know it's an irrational number, and then it will not be a perfect square. Ooh. So now we have a question mark inside that square root. Has to equal 12. How could we use our calculator to find this? I think I know you're talking about the little squared button. Yes. Which is the same thing as what would, if this is equal to 12, then what goes inside here has to be 12 times 12. Because a square root is looking for the number that multiplied by itself equals 12. And then if I know that, then I can figure out that the question mark had to be 144. Same thing for this one. If it's equal to 3/4, then inside you had to have 3/4 times 3/4. What's our question mark then? 9/16, because 3 times 3 is 9, 4 times 4 is 16. And in the last one, If it's equal to 1.8, we know that inside we needed to have 1.8 times 1.8. Does anybody know 18 squared by their? Oh. Well, 18 squared is 324, and so the answer to this question mark is 3.24. But did you use your calculator? Yes. But 18 times 18 is 324, and then 1.8 times 1.8 would have 2 decimal places, 3.24. Nice. Now, one of the things that can help visualize multiplication is areas of squares. So one of the reasons they call it a square root actually comes from the fact that if you drew a square with an area of 9 units, does it make sense that the side lengths are 3 and 3? Good. Okay. Now you're ready. We can do the same thing with different numbers and even fractions. Okay? So would you agree that here we have 4 by 4, outside is 5 by 5. So this would be 16 on the inside, 25 on the outside, and in the dotted line, the area would be somewhere between 16 and 25. Okay, I'll color code it for you so that you can see this maybe even better. I'll draw the outside square in blue. That's 25 square units. I'll draw the inside square in red. And I'll do it in green. And I'll keep the dotted line. The inside one is 16. The dotted line one is somewhere between 16 and 25. And the length of that dotted line one would be a number in between 4 and 5. So for example, does it make sense if, what's the number between 16 and 25? 18, 20, okay? Does it make sense that the square root of 20 does that make sense for you? That the square root of 20 has to be a number in between 4 and 5. It's not something that we can easily do mental math, right, unless you've had lots of practice. 4.472, 3 decimal places? How close? Square root of 20? How close was I? Yes! 3 decimal places, right. Smoked it. Smoked it. Yeah, it was like. Okay. So here they say, if we try to do square root of 22, it would be somewhere between 4 and 5. We could do an estimate, right? Then check the answer with our square root, which is about 4.7. See, now, if this had said 20 on your paper and then I said it right, you'd be like, yeah, you saw the paper. But it was different. It wasn't 22. There we go. Now, we can make our grid even go to decimals. If you wanted decimals, can you see that you could take 36 out of 100 squares? And if you wanted 0.36 as a decimal, this would be 36 100ths as a representation. Then this side is 0.6 and this side is 0.6. So with decimal multiplication, I love all of these things in mathematics. If you know that 6 times 6 is 36, you know that 0.6 times 0.6 will also be 36, but there's 1 decimal place here and 1 decimal place here, so your answer needs 2 decimal places. 0.2 times 0.2. Well, you know that 2 times 2 is 4, but we have 1 decimal place here and 1 decimal place here. We would need 2 decimal places, so it becomes 0.04. Mm-hmm. Is 1296. Okay, good. Whew. That was a big one. 6 times 6 times 36. I did pretty quick. I thought I did okay. Okay? Same thing even if the numbers are different. If you had 0.1 times 0.32, do you know what 1 times 32 is? I hope so. Is 32. But we have 1, 2, 3 decimal places, so your answer would be, with 3 decimal places, 0.032. Awesome. Okay. So what we want to do here is estimate. And with the estimate, I want you to tell me between which 2 whole numbers you think it is, and then we'll calculate it for real. Okay? So in A, let's do all the estimates first. $7.5. Would you agree that that is between 9 and 4? So our answer should be between, 2 and 3, because the square root of 9 is 3, and the square root of 4 is 2. Now, if you estimated it, you might go, oh, I think 7.5 is closer to 9 than it is to 4, so my estimate's going to be 2.7, maybe something like that, right? Then check it with your calculator. What is it actually? 2.7 something? Do we do something with an S? Is that, no? 7 something? We're going to only do 1 decimal place, and we can put 7, 3, 8, ... And if it doesn't repeat, and it doesn't end, then it's going to be an irrational number. Ooh, do you know what I would do for an estimate for B? My estimate might be, this one's close to 9, this one's close to 4. My estimate might be 3 over 2. Because square root of 9 is 3, square root of 4 is 2. That might be an estimate. Or I might change this to 1.6, right? 8 divided by 5 is 1.6. So I would estimate it to be between 1 and 2. Because it's more than 1, but less than 4. If we did it exactly, does someone have the actual answer? So on your calculator, you hit your square root button, and then 8 over 5 you could write as 8 divided by 5. Should be more than 1. Let's see. 1.6? 1.2649. So try it on your calculator to see if you can get this. Because again, we want to make sure that our calculators work for us. You may. I'll show you something really cool on your calculator. You can do it that way, but on your calculator, if you do this, and you want to, hit the alpha button, then hit y equals, which is F1, and the very n over d, push enter, and then you can actually write fractions, just like that. Oh, so awesome. And then for C, 3/10 is bigger than 0, but less than 1. Square root of 0 is 0. Square root of 1 is 1. I would guess this to be between 0 and 1. If I wanted to get even fancier with my estimates, I know that this is in between 0.25 and 0.36. And 0.25 is 0.5, and 0.36 is 0.6. So as an even better estimate, I know that 0.3, the square root of, will be 0.5 something. Test on your calculator. Someone have the actual value for the square root of 3/10? 0.547 dot dot dot. Yes. Yeah.
Where did you get the between 0.25 and then 0.3?
Well, because I knew 5 times 5 was 25, I know 0.5 times 0.5 is 0.25. And since I know 6 times 6 is 36, I know 0.6 times 0.6 is 0.36. So that, for sure, increased my abilities to estimate really well for that one. All right. And then we get into some word problems. A picture frame measures 30 centimeters by 20 centimeters. Can you mount a square picture of your math teacher with an area of 50 centimeters squared into the picture frame? So this is what we have. We can draw a picture of what's happening. We have a picture frame that looks like this. 30 centimeters here, 20 centimeters here. You have a picture of your math teacher. Oh, I know. Everybody has one in their wallet, I know. 500 centimeters squared. And since it is a perfect square, you can find the side length of this by doing the square root of 500. We'd have to go to our calculator for that. What's it going to equal? Someone needs a calculator for this one. 21, 22 point something. Dot, dot, dot. Will this fit in this picture frame? Well, it would fit in the 30 side, but it would go, you'd have to cut off my arms. Okay? Yeah, they look nice and everything, but you'd be okay. Cut off my arms, still fit it in the picture frame, right? Or maybe just decide, I'm just going to put it up in my locker. We have lockers again, right? Did they reopen the lockers? So, I think, yeah, a while ago. Last semester. But like lots of people aren't using them still because they're like, they didn't start from the beginning of the year. But yeah. But that's what you'll find, you're right? You open up lockers in the school, the number one thing you'll find is pictures of Mr. Shirk, right? In all the lockers. Right? It's called role models. All right, and the very last question of our notes. So exciting. Identify the error. Your friend has asked you to help him with his math. He wrote the square root of 66.4 is equal to 3.2. Can you see what he did? Someone said he added 3.2 twice instead of multiplied, right? Or he divided 2. So you could write he did 3.2 plus 3.2, which is wrong, and because he's your friend, that's exactly how you said it to him. You are wrong, right? Because you are so nice to your friends. Yeah, that's right. You would say, you'd be nice to your friends. I'm not going to say what you are, but it rhymes with dupid. Yeah, that's probably what you would say to your friend. And then all of a sudden you're like, why aren't they my friend anymore? Anyways, he should have done 3.2 times 3.2. And then you would find out boy, that's 3.2 times 3.2. Square root of what should have gone in here? 10 point something. 10 point, what do you got it? 10.24. Oh, I should have got that. Right? So should have got that because that's the same as 2 times 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 2 is also 1,024.
Yeah, I think you did that because
32 is 2 times 2 times 2 times 2 times 2, 5 times. Okay, so homework out of our textbook, page 78, questions 5 to 15. We are going to have a quiz next Tuesday. It's going to be on all your fraction stuff, all your square root stuff. And that means on Monday we get to start our next unit. So I'll have to get either another notes package or we'll do it in smaller chunks. Yes, Neil.